Given that the integral of a function f of x from minus 2 to 2 is 10, and the integral of f of x from 0 to 2 is 12, find the integral from minus 2 to 0 of f of x plus 2. We can sketch a function that would roughly satisfy these givens. We know that the function f is more negative from minus 2 to 0 than from 0 to 2, since the integral in the larger domain minus 2 to 2 is smaller than the integral of a portion of this domain, which is from 0 to 2. We can rewrite the integral of f of x from minus 2 to 2 as the sum of two separate integrals, one that goes from minus 2 to 0 and the other that goes from 0 to 2. We can substitute in values that we already know. So the left-hand side is 10, and we know the integral from 0 to 2 is 12. When we rearrange this equation, we get that the integral from minus 2 to 0 of f of x is minus 2. Let's rewrite the integral that we were meant to find though. So the integral of f of x plus 2 from minus 2 to 0 can be split apart into two integrals. One, which is of f of x, and the other, which is of 2. We already know the value of the first integral, and that is minus 2. For the second integral, we can find it easily by integrating 2, so that's 2x, and using the fundamental theorem of calculus to find the numerical value of the integral, so that would be 4. This means the answer to part A is 2. Part B asks to find the integral from minus 2 to 0 of f of x plus 2. This is actually a translation left 2 units of the function f of x. We can quickly sketch this by copying our function from part A and simply shifting the axis 2 units to the right. So this effectively shifts the graph 2 units to the left. We can now see that the integral of f of x plus 2 is actually the same as the integral from 0 to 2 of f of x. We already know the value of this, and it's 12. And that's the answer for part B. That's the end of this video. Thank you for watching, and I hope I helped you with this question. Please like and subscribe. Bye!